source generators. Please give Rob a welcome.
Hello, everybody here and at home. Our 2 Twitch followers.
We had 16 at one point.
Oh, really? Awesome. That's cool. All right. Oh, great. No pressure. Yeah, howdy. Thank you, everybody. So I'm a principal engineer at Octopus. I've been there for like 6 years. The company, I looked it up just before, it was 10 people when I started. Now we're 222 as of this week, which is a little bit crazy. And like I think 90 of those are engineers and 20 in others in R&D, so designers and product. Yeah, so you're gonna have to bear with me because you're gonna earn your pizza. This is what's going to pay for your pizza tonight, right? So I'm going to tell you what's new in the actual product. So for those who are working in the enterprise space, you've got ServiceNow integration, so auto approval integration for your stuff. You have there's better serverless stuff, you know, that thing that everybody's doing that nobody's really doing. No, I'm kidding. Just lambdas and just better AWS things. You've got automatically cloud target discovery. That means you no longer have to tell Octopus what is in your cloud environment. We'll just go and figure it out. So this is just the first cut of it. Yeah, so for example, it'll find your ECS clusters and Kubernetes clusters and web apps in better ECS integration. There's a Visual Studio Code extension for editing OCL. Not 100% sure why you should care when you're reading this, but further down, we've got config as code now. So that's you can now store your Octopus deployment configuration inside source control. That has been a labor of love, torment, and tears over the last 2 years. But I think we got a really good spot. So OCL is our configuration language, which is essentially just HCL without a H and an O instead. Yeah, but there's a Visual Studio Code extension to make it all nice and pretty. Finally, coming up, if you're interested in joining a alpha program, please come to our roadmap page and keep you updated, and we may hook you in and you get to influence the future. Better AWS Lambda support, dynamic infrastructure. So if you're standing up a whole new infrastructure per branch or per test run, this feature is possibly for you. ServiceNow integration. So if you work somewhere where has approvals before you deploy, that might make you excited. Config as code for runbooks. Built-in container registry. So no more going off to third parties to do that. And the thing I've been working on, which is DevOps Insights, so DORA metrics, lead times, etc., stuff like that, coming to an instance near you at the end of Q3. Yeah. All right, so let's talk about source generators. So who's used source generators before? Cool. Who's actually written one? Good, one person. Kind of somebody. Okay. Who has written actually a Roslyn analyzer to give you compile time errors? Cool. Because if you have, it's pretty much the same thing, except instead of causing errors, you cause code. Yeah, as a side effect, right? All right, so I'm going to start off with a really contrived example of I want a lookup class, which given a string returns a type. Yes, you can use reflection, obviously, but sometimes reflection is just that little bit too slow. Let's pretend it is for my contrived example. But say you're doing some sort of interpretation of something and using reflection to discover types and then doing dynamic invocation. Like if you're using reflection to do that, that's thousands of times slower than an actual direct method call. So what a lot of people resort to is using expressions, compiling those expressions, and then caching those in some sort of dictionary, right? So I'm seeing a few nods. People have done this just to get that call speed up. But you do that at runtime. But imagine you could do that at compile time and you didn't have to handwrite it. So the domain we're working with here is, I don't know, I went with a role-playing theme, we've got an enum of a class. Best thing to use in C# is something called class. Yeah, so anyway, you've got a class of your character. Your character's got a name, hit points. I've done it in a way which you can't change your name, although that's probably should be able to. But yeah, just a nice model of things you can actually set. So keep the internal DDD style consistency. Also got a method on there which gets all the equipment which has a where level of something. Of less than a certain amount, kind of amalgamates into a list. And equipment is just got name, where left, and has some enchantments on it. So really, what it really is just an example of a nested domain model. So the aggregate root being your character, and 2 or 3 levels deep of nesting of data. So for the first contrived example, I want to get the type called character. So what am I going to do? So I've created a project called Source Generator, just standard .NET library. I've in my consuming project, I've imported it with the output item type analyzer. Now, yep. And going back to, and then in the source generator, there's a couple more imports to get the actual C# compilation stuff and tokens, plus the analyzer plugin, because that is what it is. It's an analyzer that modifies your actual compilation. All right, so my lookup source generator. Here we go. So I've chosen this simple example to start with because it doesn't require you to inspect the actual semantic tree or you can just go it off the actual syntax parser. The other times you could do this without looking at the syntax is, the semantics is, say you were doing a GPRC service. I don't know if anybody's used the .NET GPRC plugin. Yeah, you can write your stuff in a proto buffer definition file, and it automatically generates the classes for you. I was hoping it would use source generators, but it doesn't. It does compile. It does design time transformation of the file into C# classes. But that means you have to edit it. Sometimes it doesn't work, and yeah, it's a bit annoying. And also the IntelliSense doesn't really pick it up as well. So you could do the same thing in proto buffers. You could write something that change your proto buffer definition file, YAML, whatever files you have, an external file. You pick up some configuration file and transform it into actual C# code without actually having a look at what the semantics of your actual application are. So I think over the years, lots of people, many people have done this. XML file to generate code, JSON file to generate some head in hands, yes. Just all the way to get out of writing actual C# code. Auto-gen everything from the top to the bottom, from your web service down to your database layer from a XML config file. And then we discovered that actually writing code is a much better idea. So I'm saying this with a caveat, like you could imagine to use this for the same kind of thing, but most of the time, probably writing code is your best bet first. Write code first. Once you see something that you're just repeating over and over and over again, automate it or use reflection to do it. One example we discussed was at the moment our ASP.NET controllers, they basically take a message off from the input on a URL and throw it off to mediator to go do something, right? And that's very much boilerplate. What does the controller do? It tells you what the route is. I don't know what else it does. Emily knows more than me about that one, but yeah, it doesn't do much. It doesn't even apply security. It may do some sort of mediation between the inputs or between the route and the data and body. All right, enough about that. So contrived example. Right, so I've created a class called lookup source generator. Tagged it with the generator attribute, which tells the runtime that this is a generator. What we want to do, there's two methods you have to implement when you have an iSource generator. An initialize method, which runs right at the start, and then an execute method, which runs when the compiler wants you to spit out your source code into it. So on the initialize stage, if we were doing this from a file, like a set file, you wouldn't need to do this because you don't need to know what else is in the application. But for my example, I'm generating a switch statement based on the classes that are in the same project. So I'm registering a syntax receiver, which I've nested in here, which has a single method called onVisitSyntaxNode. And every time in the syntax tree it sees it, this method gets called. Now, a lot of these two methods, they're both the onVisitSyntaxNode and the execute, just like an analyzer, they're really hot paths, right? You want your IntelliSense to go like this. You want your compilation to run in seconds. So if you're doing too much or too complicated of an algorithm here, it's really going to slow it down. So I pulled, there's a analyzer that for cross-platform compatibility that we were using. We had a look, and it was taking about 30 to 50% of the actual compile time when you F5'd. You change a file, F5, 50% of that time was just checking everything to make sure it's still compatible on Linux, right? Which seemed a little bit nuts. And it was deprecated, so we took it out. But yeah, so whenever you're writing these, keep in mind, I'm going to point out what the expensive things here are. All right, so if you're wondering about the syntax node, there should be what a syntax node is. There should be a view, other windows, syntax visualizer. You can actually have a look at what the syntax tree looks like for your class. There we go. There we go. We've got there's a file scope declaration. You've got a class declaration. So each of these are a syntax node, each of these orange things. Right? So there's lots of these already in this class. So imagine a large code base, there's hundreds of thousands of these things. This window is also useful to figure out how to interpret the compilation and what you're dealing with. And what metadata is available during compilation.
So the input is exactly C# to the source generator.
It is, yes. But this syntax visualizer is just showing this C# class I've written here. Yeah. So just to be clear, so if I go to program, I've got the using directive up there and global statement. So this tree, the syntax tree, is the thing you've got access to during compilation. During the source generation. Cool. So I'm going to close that. So what we're interested in this case is all the classes. I just want to capture all the classes during this compilation. So I can go if the syntax node, nope. So I've just started using Visual Studio a couple of weeks ago because Writer was getting too slow for me. Try it. It's an irony actually. Because lots of people swear by. But yeah, Visual Studio 2022, pretty good. So if it is a class declaration syntax, I better give it a name. CDS. I'm not 100% sure about the code autocomplete thing yet. What's that called? The thing GitHub wrote. Hey? Copilot, yeah. So we'll add all classes. .add. Yep, there you go. Thank you. All right. So every time we get this is my receiver. Every time we encounter something declared as a class, we'll add that to our thing for later processing. All right, let's do our later processing. The thing I want to create is, I'm going to type it in C# code. I want a public class, my lookup, and I want a public static thing that returns a type. Get, I think string, is that right? I called it get. That's my program. Yep, get. Get based on name. And I want to switch based on the name. and if you know case, it's called as I said, they occasionally let me code return type of, you know, that'll do. Okay, so that's exactly kind of what I want to write. I want a default case, obviously. New. Yeah, I'm going to replace it in a minute. English isn't my first language. That's my excuse. Sorry?
Line 31. That if statement with no space before the brand, just I can't.
There you go. Happy?
Thank you.
Control Alt Enter. I haven't saved the file because Control Alt Enter Control S is my muscle memory, right? All right, so that's the class I want to create. So I'm going to go up here, okay, var source. This is a little bit of an annoying bit about this is you have to write this in actual full C# code. Yeah. So thank goodness this time I have ReSharper installed, so that auto escaping works. Right, and then I guess for all my classes that I get from my syntax receiver, just some sort of check. The Docker has this in there, but I don't know why you would get something different. But anyway, always best to check, eh? Be a bit defensive. So for all the classes I've captured, I'm going to create a line called with this string in it. Right, oops, sorry. Boom. Escape. There we go. Case. Let's do string interpolation. There you go. And instead of character, I'm going to throw in the class declaration syntax, the identifier value name. So that's the actual name of the class as it's declared. All right, and I am going to return the type of same thing, right? I'm actually going to call C# get type. As I said, contrived example. And I'm getting thrown off because of the big font size and I can't see everything I've written. So I'm going to select that, right, good. All right, so that's my cases. And then I'll do a case str, which is a string.join, environment.newline, cases, yeah, cool. All right, string concatenation, not quite, but there we go, okay. Nope. Yeah, thank you, ReSharper. Cool. All right, so I need to have the using statement as well. I need a namespace example.domain. Right. Okay, cool. All right, I'm going to compile, and hopefully it works. Build failed. Damn it. Does not exist. Oh, actually, I'm going to turn off IntelliSense here. IntelliSense build only. There we go. Okay, build. Let's try again. Rebuild. Uh-oh. Okay, something's gone wrong. Right.
The string that you made?
I bet you I do, yes. You're right. Oh, no, I do that. Oh, yes, thanks. Yeah, okay. Final step. Context. Actually, this would be a good way to say, oh no, it's not working, all right? So let's debug this. Best way I found to do is just chuck a debugger launch in there, in the initialize, press F6 to build. Thing comes up, and debug the Visual Studio that's building your thing. All right, F5, and here we go. We can step through the thing. Right, I can see your cases string. Come on. Yeah, anyway, watch locals. Where's my locals window? Here we go. There I go. I've got my beautiful generated code. And yes, you're right. I need to add a context. Context dot add source. got to give it a name. So this will be my lookup.g.cs, a bit of a convention, G for generated, in source. So this now contributes it, plugs it into the compiler in memory, C# code, and the compiler magics it up, and hopefully this will work this time. And I didn't take the debug out. Let's take that out. All right. Oh yeah, cool. Cool, I didn't have a default label in there somehow. What's happened now? I've just clicked on the error and it's gone to my generated code. So let's find out how that happened. So in my Solution Explorer, if I look at my example file, expand out objects, debug, net60, generated, source generators, blah, 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 all the way down here, that's where my code generated file comes out. It only happens if it manages to generate it successfully, gets past the kind of first parse of it and into the, you've done something wrong here. That's controllable. It's off by default. There's a line in the project file which is emit compiler generated files. So if you switch that on, you get to see all your beautiful source code. Yep. So what's that saying? I did not put a throw in there. Who picked that up? Extra points. Maybe you picked up the space, but not that I didn't put a throw in there, right? Now, worst mob programming ever. So all code are just strings inside text files. They're all ones and zeros, right? All right, we have a successful build. Brilliant. So going back to program. All right, so if I now debug this, run it. Drum roll. Cool. It prints out the actual type, right, that it's found, right? Visual Studio, the IntelliSense is a little bit upset still because IntelliSense only picks up the source generator at the start, the first time you run it. So if I exit Visual Studio now and reopen it, and luckily it's fast now, so we're not going to sit here waiting for 3 or 4 minutes. Okay, well, it loads all the things. It keeps on telling me to turn off ReSharper, but I'm like, oh, yeah, even with ReSharper, yeah, as you can see, it's not as bad as it used to. Okay, all right, and voila! As soon as this time, as soon as ReSharper catches up, it'll go blue. I'm hoping. Come on, go away, error. Build. Oh, I'm not plugged into it. That's why. Okay, I'm not plugged into the power. So these things throttle like there's no tomorrow. There's no way to change it in the power settings. Okay, cool. Yeah, there you go. So right, it's caught up. Cool. Onto a less contrived example, and I'm not going to write the list. Yes, Todd. No. It even catches up in memory. Yeah. So I can prove that by going. If I go, okay. I can't do it yet because I'm not contributing extra classes to it. But it does it in memory. Yeah. All right. So I'll show you that example. So next is an actual. I need to reset. It's okay. I'm a .NET developer, so I can use GUIs. So don't yeah. All right. So now I've actually created some data. I've got my character Bob, who's a sorcerer, 100 hit points. He wields a spoon of healing, and he's just walking around with a carrot and a big Lamborghini Countach, one of the most classic cars ever. Anybody play Stunts back in the day? Yeah, Countach was the car to drive in that. Right. What I want to do in this example is, say your application that happens to do deployments has an in-memory cache, right? And so, which persists across requests of your domain object. So, say you read, a whole set of things out of a database, tens of thousands of things, and you cache it for a set amount of time or some other method, right? What you don't want to happen is any code goes and changes those things and doesn't persist it. What you really want to do is make that cache read-only. And if you've got your domain entities, they can be modified by accident. One developer might go, you may have put it behind a facade, going, okay, get me these things. Somebody grabs this object, doesn't know that it's cached, goes and passes in somewhere else. That somewhere else modifies it, right? Unexpected. So what we want to do is actually make that read-only. How would we do this, without source generators? F sharp. True. Then there is no mutation of state. Okay. On the assumption that you're using, domain objects that are mutable. Okay. You would write a mirror object and then write left to right mapping code, or if you're brave, use automapper to copy from one to the other. Same thing like external resources, passing it out to the API, you're doing almost the same thing. There's almost a one-to-one relationship between the two, right? And in the 90% case, they're the same. And yeah, so you either write that by hand, do some sort of code gen, or I don't know, some auto mapping style thing. So what I'm going to show is that I want to turn this character with a single extension method called toReadOnly, turn it into an actual read-only object all the way down the hierarchy tree, right? So this should now run. If I go F5, first we want to prove that it actually works. There we go. What do we do before source control? Output. Where's my? Still in living memory. Zip files here. Right, left hand. Here we go. All right. So here's my read-only thing, right? You can now see the types. I've got a character read-only, and the list of inventory is an I read-only list of. Where are we? I don't know if that's too small to see. I don't know how to make that bigger. Have we got a magnifier? There we go, magnify app. All right, that way. So you can see it's actually now I read-only list of equipment read-only, which I have not defined, written, and hand on heart, I have not written that anywhere by hand. All right. Who uses magnifier? How do I get out of this? There we go. Alt F4. I don't do in-person presentations. That's what Zoom is for. People can use their own magnifiers. All right. So let's have a look at just out of curiosity what the code is generated, but it's mostly just for example, right? So I have created a character read-only, which is an exact copy, except for the I read-only list, and my domain entities are now also postfixed with read-only, right? And it's kind of the same thing all the way down the tree. I've used records because are records immutable? Come on, are records immutable? Oh, they're not. No, they're not immutable. You can have setters on records, but by convention, people make them read only. So this is immutable if you write it this way. Yeah. Anyway, so yeah, and then there's a set of extension methods which convert this thing to the other thing, right? Left to right mapping. So I've got a toReadOnly extension method on character, which does all the magic things that have to happen for it, right? All right, let's have a bit of a look at how this actually happens. So where's my read-only source generator? Here we go. All right, I'm going to debug through this. All right. So again, I've got the syntax receiver, which is receiving all the classes. For each of the classes, I'm calling this thing called GetSymbol. GetSymbol actually returns more than just the syntax around it. It gets some of the semantics around it. It's already resolved what the types are that you're calling, so you know what the namespace of the types are, what methods are on that thing, what interfaces it inherits, all the way down the tree as well. So just like reflection, so it's about 80% of what you get in reflection is here in the GetSymbol thing, of that metadata of your code. Yeah, so this line where you get the syntax tree, which is the point inside your compilation text, it goes back to compiler and goes, get me the actual symbol that's at that spot. And that is really expensive. Like, you want to do this as little as possible. So my recommendation would be, even for analyzers, is bail out as soon as before this point. So if you can look at something like the namespace name or something else within the file, the class name, the something, and to bail out of your analyzer before you have to get the syntax tree, do it, because it'll save you hours over every year of actual compile time. All right, so yeah, so we get the semantic model, and from that we get the symbol that's declared there. And since it's a class, it's a type symbol, right? Yeah. So I've just got a couple of helper methods. You know, should it be made read-only? They're my business rules, and then good old string builder. Again, this code should be fast, so I could have used the templating language. You know, I could have done a few other things, but you know, string concatenation works, so why not? I could have used Razor, but how long is it going to take to spin up a Razor runtime to compile this thing to C#, right? But it's not prescriptive. Somehow you've got to get a string. The add source thing actually also, you can have use source text. You can actually also get it from a stream, text reader, a buffer, or a string, right? So maybe you've got some other way of doing a text writer. Text writer is probably more efficient, but yeah. Anyway, there's options there. But basically, let's debug this. Actually, if I F6 this, I should be able to. I can tell you the things. Let's see. Okay, source generators. All right. Continue. Let's go down to here. Here we go. All right, so you can see this kind of metadata we get now. So this is for each of the types, I've converted each of the types to symbols and called it entities. So for each of those classes, I can get its namespace, you know, full namespace. I can get all the public properties that are declared on it. I don't have to try and parse that C# file to find out what it actually is, like used to. If you use CodeSmith, you'd have to do a double compile, because you have to compile to get CodeSmith to pick up the actual files, to then generate the source code, and compile again to pick up the new source code. It's yeah. Anyway, you get public properties, so yeah, you can basically just spit out all the code. I might leave that one there. It's basically just all sorts of code. There's a couple of interesting things like this. You have to put that in there because it doesn't pick it up from the project. Things like that. Okay, so an alternative way of doing this whole thing is a read-only.
So
Yep.
Do source generators, do they affect the analysis that you have available to you for other source generators? Like if you have a source generator that generates.
Yeah. As far as I can tell, no, because even if you output a new class, it doesn't get called back on this visit syntax node. Doesn't get called again. Otherwise, it'd be turtles all the way down, right? Where is he? Yeah. I thought about that. Yeah, it doesn't appear that way. So it looks like there's two stages. There's the main compilation of files. Everything gets contributed. Probably that's why you have to. It doesn't pick up the nullable annotations, as in rules. Like if you do something wrong in that, other analyzers won't run. It'll only run if the compiler breaks. Yeah. Possibly it's got to do with the way they're loaded in order as well. Maybe if you load them in a different order, I'm not sure. Yeah. So another way to approach the read-only thing is, where are we? Nope. Got to compile first before I'll generate my code. Here we go. Is actually use interfaces. So actually have the same class, so you don't do a left to right copy. And you decorate. So here I've used partial classes on my character, and I auto-gen a interface which matches the class of all the public methods, or public properties as only getters, and any methods I've marked as pure. What this means, if I do it this way, is I can actually call any of the methods marked pure. Pure means there's no, you promise there's no side effects. So I don't think it's forced. Maybe it is. Maybe there's an analyzer for that. But yeah, so you can actually, on your read-only models, you don't have to have the same methods again. Like this get equipment with where less than method still works. Because on the character, I've used partial classes to generate the other half of this character, get it to extend my read-only character, and just forward everything from the explicit implementation of the interface to the actual implementation, right? So somebody could theoretically cast iRead-only character back to character, but write a source generators, analyzers so they don't do that. Or just tell them really hard, don't do that, because why? Just don't. Yeah. All right. I think that's it for the code demo. I'm just going to finish up with the actual slides, which I've already covered. This is just my notes that make sure that I haven't missed anything. Right. As I said, don't start with code generation. Don't go build a framework, please. Unless you're going to sell a framework, of course, then go ahead for it. Try and solve a real, not theoretical pain. So don't whip this out because it's a beautiful architecture. As I said, a lot of us have done this in the past and it's never ended really well. Consider reflection or generics, whether that's a better option, probably more maintainable option. They're really useful when all information is known at build time in advance. So if you're using dynamic loading of things or plugins or something like that, it's really not going to work. Use it instead of expression buildings. Pros against reflection or runtime generation, you actually get line numbers where things go wrong. If you're ever deep in reflection land and this convoluted code which is trying to wire things up and new things up, like inside a container, it's just big mystery of what's actually going in there. You can actually, with the debugger, you can actually step through actual code. And it's really fast at runtime. It's as fast as actual code instead of reflection. Cons, it can really slow down your build. As you can see, concatenating strings is messy. Applications, I've talked about that one. Oh yeah, if your ORM can't handle really nice entities, it really needs just POCOs or everything public like EF used to. That'd be a good thing. If your resources, maybe, if your serializer doesn't, although JSON.NET is pretty good these days. One use is EF still can't handle dependence objects, right? If you've got a relationship object, you can't put that in through the constructor. So it really messes up your nullable annotations. Yeah, server-side contracts from TypeScript. Maybe you should, instead of, define your contract in TypeScript of what you want to receive and generate your C# class from that instead of the other way around, which a lot of people do. And that's it. Further reading, Google it. Getting started with source generators and source generator cookbook. Yeah. Or watch the video and click on the links. Good luck. Thank you. Have we got time for some questions? Or yep. Any questions? Good, because I'm not an expert in this. No, go on.
Yeah, your IntelliSense didn't pick up the generated classes
Yes.
Now those generated class will be regenerated every time you build. So does that mean essentially every time you build you need to restart?
No. Okay, so the IntelliSense only uses the source generator that was there at the start, or the first time it got built. So, for example, if I now add program, it's going to want me to restart. But say I add a new class to this, I can then automatically the iRead-only will appear in the IntelliSense right away because it does run. Yeah, if you change the generator, you're not going to get the new behavior in IntelliSense, but you will in your build. Yeah. Cool. Any other questions? Yeah.
Bit of an academic one, but if you were to package this up as a NuGet pack with symbols, do your symbols include generated code?
I have no idea.
Homework.
Yeah. Well, yeah, the source generator is normally distributed via NuGet, but would it? I reckon it would.
Because you do get line numbers during debugging, so presumably it's in the
Symbol somewhere, yeah. Yeah. Actually, somebody, after they gave the talk internally, they said, hey, could you build a container out of this, like a statically compiled container? And pointed me to a Java one. And I said, not me. I'm not doing that. Good attempt at nerd sniping, but no, not today, young'un. So, yeah. There you go. Okay, so I've had time to restart. So if I add to my domain class, public class, I know what am I going to do? A robe. Oops. I can code what? Oh, I can want partial. Right. See, it's already picked up that it needs to be a partial because it's already generated the other half of the class. There you go. Partial. All right. And if I go in here now, I've got a new. Robe read only. Read only. Well, have I got that the wrong way around? Hang on. I did read only here. Read only robe is there. Right, it's already picked it up in the IntelliSense. Cool. All right. I think we want to go home or for a beer.